Myself, Dr. Pradeep A.R., working as an associate professor in the Department of Civil Engineering. I am going to give an introduction regarding design of steel structures, an overview, how the steel structures are going to be designed, how they are origin, what are its advantages and what are its disadvantages. So, everything we are going to cover in this unit. So, coming to the contents, introduction, classification, advantages, disadvantages, properties of steel, specifications and a sectional classification, different types of sections and section classifications, loads and load combinations, design considerations and methods of design, particularly limit state method of design. So, coming to the steel structures, what are steel structures, why they are going to be constructed, how they are going to be constructed. So, steel structures having its own advantages, particularly it is a structural steel, it is a load carrying capacity of the structural steel will be more compared to the RCC structures, and it is having a lifespan, more a larger lifespan. So, today we are going to come across with the many number of RCC and steel structures. So, why we are going with the steel structures means it is having their own advantages, that is its construction will be very easy, or if the land is not available, if the land is given for the lease, at that time we have to go with the construction of steel structures. So, the land will be taken as a lease from the customer and he will be constructing the structures temporarily. So, at that time if they construct RCC structures, it will be a difficult task. So, at that time construction of steel structures may useful, so that after the period of the lease they can demolish or deconstruct, dismantle the structures and they can shift to another place. So, coming to the steel structures, so steel concrete composite structures are also used in high rise structures, buildings, as we are going to use only in a broader way of study. So, from structural point of view, they are classified as shell structures, that is gas holders, blast furnaces and steel pipings. So, coming to the framed structures, so buildings such as factories, roofs, transmission towers and platforms. So, here we are going to construct these steel structures. So, common steel structures are roof trusses in factories or in warehouses or in large scale buildings, industrial buildings, cinema halls and in railways. In railway stations we can see come across with the skywalks, there also we are going to use steel structures, crane girders. So, crane girders and columns, some sort of columns, and sometimes we are going to use the plate girders, crane hooks and bridges, transmission towers and water tanks, so chimneys also. So, here we can come across the various types of steel structures. So, coming to the steel structures, here we can see the beam and column connections, they are connected through some connections, it might be welded connection, it might be bolted connection. So, here it is a steel structure, it is a framed steel building structure. So, in this structure we can see the beam and columns which are ultimately made up of steel. So, they are made up of structural steel itself only the slab component is made up of the concrete. Sometimes steel will be used as a composite material in case of concrete also. So, here it is a framed structure which is a building structure. So, this is the industrial building. So, in this industrial building we can come across with the steel sections which are made up of I section, channel section, or different types of sections might be used based upon the types of loading that is going to be acted on that particular structure. So, here we can see these are the factory buildings or warehouses, they are where we are going to come across with the industrial structures. So, this is a institutional building, it is located in IIT Hyderabad. So, this is entirely a steel structure, this is an institutional building. Here also they have made the structure with the steel, beams, columns and bracings are also have been provided. So, bracings will be bearing the load in the diagonal directions. So, coming to this is a geodesic dome building. Here the structure is made up of tubular sections and with spherical nodes. So, tubular structures are going to be provided at the joints, they are going to provide with the nodes. So, these nodes will be acting as a connectors. So, from these connections only the forces will be acting, it might be loads or it might be in the form of compression or tensional forces. So, here we can come across with the steel truss bridge. So, in steel truss bridge we are coming across with the forces compression and tension forces. These two forces will be combinedly acting. So, to hold this structure in the stable form, it has to be bared. So, it will be designed in a easy manner by using steel structures. So, whenever there is a dynamic loads or moving loads, at that time we are going to construct the steel structures itself only. If it might be railway platforms or it might be railway bridges, at that time the dynamic moving loads will be there. So at that time we have to go with the construction of RCC structures is difficult. So steel structures will be used as a steel truss bridges. So this is also an example for steel truss bridge. In this steel truss bridge, we can come across with the cantilever portion. Along with that, bracings are going to be provided. So this is a road bridge also be provided in this structures. So this is also cable stayed bridges. So in cable stayed bridges, we can come across with the different cables which are made up of steel. So they are a composite. It might be either RCC or it might be PSC, and they will be connected with the steel connectors. So cables are provided in the form of tendons also. So these cables will be transmitting the forces, compression and tension forces to the deck, that is the deck slab of the bridge. So coming to the advantages and disadvantages of steel structures. So why we are going to use steel structures? So it has having its own advantages. Steel structures will provide maximum advantages and minimum disadvantages. Coming to the advantages, it is having high tensile strength as per unit, and their density is also high. Compared to the density, it has a low construction cost compared to the RCC structures, and it is having long service of life. So it is having higher service of life compared to the RCC structures. So it might be high scrap value. It is also having good aesthetic view also. So using of steel structures will provide longer life compared to any other RCC structures, and compared to the RCC structures, it is having good durability. Durability means lifelong. The span will be lifespan will be more, and also they are going to provide with the ease to assembly and dismantle. Construction is very easy, dismantling is also very easy compared to RCC structures. So hence it is going to be having its own advantages, and it is having high scrap value. So even though after dismantling also we can get the higher values, that is a recycle value, and it is having eco-friendly. So that is a environmental friendly. It doesn't create any raw materials are required. For that purpose, the factories and all to be established that may release poisonous gases, but construction of only steel may reduce its cost due to the demolition and its reusability. So coming to the disadvantages, it has having two disadvantages, that is high cost, that is initial investment is high. So initially we have to invest high, so that is one of the disadvantage. Next is corrosion. So steel may undergo easily corrosion, so that is one of the disadvantage. So we have to overcome by providing some coatings, so which is one of the disadvantage. Another one is it has low fire resistance. It can easily catches the fire compared to RCC structures. So these are the advantages and disadvantages of steel structures. So coming to the steel production, how the steel is going to be produced. So steel is produced, that is first iron is extracted from iron ores like hematite, limestone, magnetite, and in furnace they are going to be filled with the oxygen and is passed through molten iron to remove carbon dioxide and to make it steel. Manganese is added in the steel to make it a strength. So it will be added in a certain percentage and then it will be increased. Semi-furnished products from the machines has to be rolled in hot to different sections like bars, plates, angles and sections. So as per the requirement, they will be manufactured into flats, steels, I section, channel section or angle sections. So adding carbon increases the tensile strength to the molten stage of that is steel, and lowers its ductility and toughness. In building we use structural steel which has low carbon of which is up to 1.1% to the ductility of the yield. And the properties of steel, what are the different properties means, it is having density of 7850 kg per meter cube, that is 78.5 kN per meter cube. E is equal to, that is modulus of elasticity 2 into 10 to the power of 5 Newton per millimeter square, and Poisson's ratio is taken as 0.03. So mechanical properties, particularly various grades of steel are available, that is Fe410. So here we can come across with the Fe410, that is Fe means that is iron, 410 is the ultimate tensile strength, and here it is yield strength which is between 250, 240 and 230. So here the A value indicates the grade, which grade, A grade, B grade and C grade, and W is indicating whether it is a weldable or boltable. So, Fe is nothing but iron, 410 is the ultimate tensile strength, and W is indicating the whether the connection which is suitable for welding or bolting. So, ductility, ability of material to change its shape without fracture. Mild steel is having high ductility, high carbon steel, low ductility, toughness and brittle fracture. So, ability of the material to resist impact load like earthquake and seismic, that is wind loads or any other loads that will be occurred. So, requires both strength and ductility. It requires both strength and ductility. At low temperature, steel fails to increase due to the reduction in the ductility. So, due to the ductility, it may reduce the strength. So, and also called as brittle fracture. It is going to cause brittle fracture. And it is temperature, at high temperature, strength reduces obviously. So, next is corrosion, that is one of the major default, that is steel corrodes in moist air. So, for that purpose we have to provide some coatings. So, seawater and acid adopt painting, metallic coating, and also using corrosion resistance to steel to resist the corrosion. So, next is hardness. Coming to the properties of one of the important properties of steel is that is hardness, resistance of the material to intentions and to scratching. So, Brinell's hardness, Rockwell's hardness and number are used to measure the hardness of the, that is the structural steel. Coming to the fatigue, so damage of the material to the cyclic loading. Due to the cyclic loading, it is may undergo damage and occurs due to the moving loads and vibration on the structures. It might be building or it might be any bridge. So, residual stresses, latent stresses present in the structural steel may due to the uneven heating and cooling due to the steel making. So, this is one of the default which is used to be residual stresses. And stress concentration, under loading stress is concentrated to the places at abrupt and a change in geometries like holes and bolts. We are going to connect the steel structures through some of the connections. It might be bolts or it might be welding. If we are drilling the holes, it may undergo this stress concentration. So, coming to the steel sections. So, various types of steel sections are going to be available. So, what are the various types of steel sections? That is I section, channel section, C section or angle sections. So, various sections are available. So, they are manufactured based upon their requirement. So, the steel bars, steel tubes, steel flats, rolled sections are going to be used, which are as connected required. So, in this slide we can see I section, angle section, high strength steel, that is a box section, there is an I section, there is a I beam section and there is a channel section. So, requirement T section, I section, channel section or rolled sections are going to be used. Usually they will be bearing maximum loads. Based upon the loads they are going to be calculated and based upon the aesthetic view also they are going to be designed as per the requirement. So, here we can see a transmission tower. In this transmission tower we can come across with the various types of members. Sometimes they will be connected with the I sections, angle section, channel section and flat bars also sometimes be used. They are connected through the connection, it might be welded or bolted. They are high rise structures. In these structures maximum loads will be acting in the form of compression, tension and along with that wind load will be acting on it. So, it will be designed in a safer manner so that the tension force will be acting in these cables also. So, these forces has to be overcome. Based upon these loads the section will be chosen, I section, channel section or angle section required. So, coming to the steel I section, they are classified as ISJB, Indian Standard Junior Beam Section, ISLB, Indian Standard Light Beam Section, ISMB, Indian Standard Medium Beam Section, ISWB, Indian Standard Wide Flange Beam and ISHB, Indian Standard Heavy Beam Sections. These are I sections. Coming to the rolled steel I sections, they are example ISMB. What does ISMB stand means? Indian Standard Medium Beam. This is 500 is nothing but the length and at unit 0.852 kilonewton per meter, which is indicating the unit weight of the member. So, this is the front view of the I section. Here you can see the thickness of the flange and here we can see that overall depth. So, this is 500 means this is the overall depth and this is the breadth of the flange. So this is the depth, overall depth is going to be considered, which is small d. So here ISMB 500 means this depth is going to be considered. Unit weight of the steel is 0.852 kilonewton per meter. So here we can see the I sections which are combinedly joined as a beam and column section. So beam and column section are joined here through a welded connection. So next is a typical view of beam column in a particular floor. Here the slab will be there. From the floor itself only it is connected with the beam column section. This junction is going to be connected through any bolted or welded connection. Usually if it is a low rise structure, we are going to construct through welded connection. Based upon the load occurring, we are going to connect whether bolts are used or welding are to be done. So next is rolled steel channel section. The name itself indicates channel section, C section. So some channel sections are ISLC, ISMC, ISSC. So these are the basic channel sections. In this form we can see it is a channel section. So this is the width of the flange, this is the overall depth, and this is the section which is having the web portion. So here ISMB 300 at 0.351 kilonewton per meter. So 300 is nothing but the depth from this end to this end. This is the web portion where the D is going to be called, and at 0.351 kilonewton per meter is the unit weight of that particular channel section. So some channel sections we can see here, they are going to be selected based upon the design. They are manufactured readily and they are going to be placed in this as required. So here next is rolled sections, that is ISA angle sections. There were two types of angle section. One is equal angle section, another is unequal angle section. In equal angle section, both the dimensions are same, 150 into 150 into 12. So coming to the unequal angle section, it is 150 into 115 into 12. So this dimension is not same as this dimension, and this is the thickness of the given plate. So here we can come across with the angle sections. Sometimes we are going to use double angle sections, we are going to use single angle sections based upon the requirement. So they are going to be classified as angle sections, equal and unequal. Next is rolled T sections. So T sections are going to be used. They are having double flange. Both the sides the flanges will be there. Along with that they are going to provide with the depth. So here the depth is H and B is the width of the section. Here we can come across with the ISNT, Indian Standard Normal T section. The T section is ISNT, Normal T section. Next one is HT, ISHT, Indian Standard Heavy T section. And next is ISLT, Indian Standard Light, that is special legged T section. Next ISLT is Indian Standard Light Beam. So these are the four sections which are usually preferred in T sections. So why I am using IS everywhere means they are going to be designed as per Indian standards. So Indian standards are going to be given these sections and their dimensions are being specified by the in the steel table. So whenever you are designing any steel structure, you have to select these sections from the steel table itself only. Next, other sections are steel bars. So we are going to select steel bars, that is ISRO, Indian Standard Round Bars. So round bars are going to be selected. ISSC, that is Indian Standard Square Bars. And next, steel tubes, steel plates and steel flat sections are going to be used. So based upon the requirement, these steel sections are readily available. So they are going to be taken for the design of the steel structures. So next, coming to this framed structure. So this is a braced frame structure. So when the load is more, and at that time the section, it might be I section or a channel section, the beam column junction cannot bear the load. At that time we are going to provide them through braced connections. So here we can come across with the bracings that are going to be provided in the form of diagonal members. There might be double bracing, there might be single bracing, it might be X bracing, or it might be V bracing, or it might be chevron bracing. Different types of bracings are available. So here we can come across with this diagonal bracing. Next, moment resisting connections. So here the moment will be acting at the beam column junction. So these moments can be resisted by providing maximum loads. So this is a core and suspended floors. Here we can come across with the both circular section, angle section, diagonal section and moment resisting section. So both the combinations we can come across, and hence they are going to be designed. So this is the gable frame. So here we are going to provide lattice, that is tapered portal frame, lattice girder, pylon and knee bracing, cable stay bridges and suspension bridges. So these are all the maximum steel structures where we are going to use different types of materials. It might be I section, channel section or braced section. So next, choices of the section. What are the basic governing things that are going to be mentioned for selecting a suitable section? They are sectional properties and availability, and whether they are suitable for a particular section, whether they are particularly selected in a particular location based upon the load, tensile load, compression load, and what type of factors which are going to be considered, is there a seismic area or a non-seismic area. Based on that we are going to select. So if most popular sections in India are ISMB, so Indian Standard Medium Beams, ISMC, Indian Standard Channel Section and Angle Sections. So usually we are going to provide ISA, it might be equal angle or it might be unequal angle. So it is going to be called as angle sections. So channels are used in purlins. So in purlins means the horizontal members which are usually provided in the roof trusses. So from one roof to another roof we are going to provide through the purlins, and T and angles in truss and I sections. So usually we are going to provide I sections and T sections which are beam and column connections. And next, other forms of sections are built up, stepped, wide flange and hybrid and cold form structures. So in these structures we are going to use steel trips, that which are going to be in the form of steel plates. So here this is an industrial building, warehouse building, where the span is very large. So in this span we are going to provide intermediate members. So intermediate members are connected through these members. These members are going to be called as purlins. So here we can come across with this beam and column junctions. So here these are the major components. It might be angle section, channel section or T sections which are going to be frequently used. So this is a roof section. In the roof we can come across with the skylights and roof cladding and roof grubbing, and aluminium windows are going to be provided and lowered, and roof jack is going to be provided, and wall cladding is going to be provided, double slide door and roofing bracing is going to be provided. So coming to the loads on the structures. So various loads are going to act: dead load, live load, wind load, seismic load, accidental load and a blast load, snow load, erection load and wind load. Various temperature stresses and temperature forces are going to act. So these loads are considered in the design of steel structures for their suitability based upon the location, whether it is located in the seismic zone, whether it is located in higher altitude. If it is at a higher altitude, we have to consider wind load, and if it is at a very seismic severe zones, at that time we have to consider seismic loads. So seismic loads will be calculated by IS 1893 code as per the year, that is 2016. And here we can come across with the various other types of loads also: dynamic load, erection load and temperature stresses and pressures on the liquids. So coming to the dead load and live load. So dead load is nothing but the self weight of the structure. The self weight of the structure is based upon IS 875 part 1, 2, 3. So similarly live load is connected. So live load means crane load, dust load or any impact load, hydrostatic load or earth pressure. So these are the basic loads which are going to be considered in the design. So coming to the loads, we are going to combine these loads with another loads, that is a load combination. What are the various load combinations considered in the design of steel structures? Means firstly we can use dead load singly, or dead load plus imposed load. Imposed load is nothing but live load. Dead load plus live load, or dead load plus wind load. So sometimes we have to calculate the wind load if it is a wind prone area. If it is a high rise structure, at that time wind load is to be calculated, or dead load plus seismic load has to be calculated. So if it is a seismic prone area, dead load plus seismic load has to be calculated. Neither we should calculate dead load plus wind load plus seismic load at a time. So any of the one lateral load has to be considered in the design. So next is dead load plus erection load plus wind load or dead load plus erection load plus seismic load. So, any of these load combinations has to be considered. So, design philosophy. So, whenever you are designing steel structures, what is the basis of the design? So, how they are to be designed? So, what are the Indian specification codes are describing them? So, as per Indian that is a steel structures design, IS 800-2007 code is going to be used in the design of steel structures. So, this design is based upon the methods of design, various methods. So, first method is working stress method, second method is ultimate load method. Nowadays, we are going to come across with the limit state method. So, coming to this working stress method, stress at which the material starts to yield is taken as permissible stress for the section. So, this is the main criteria in design of working stress method. All sections are designated into not to exceed the permissible stress, that is permissible stress is equal to yield stress divided by factor of safety. So, this was the main consideration considered in the that is working stress method, that is permissible stress is equal to yield stress divided by factor of safety. Next is, since the steel can resist load after yield point, following the principle results in bulky uneconomical sections. So, this was the main basis for working stress method. So, the sections were very large. So, bulky sections were taken and it was uneconomical. So, hence it was going to be overcome by ultimate load method. So, that is plastic design method. Permissible load is a load when all the fiber in the steel is yielded. This method does not ensure the serviceability. So, whenever we are designing any structure, it should ensure strength and serviceability. So, this method was not ensuring serviceability. So, hence this was also depleted. So, later came into the method limit state method. So, limit state method was came into across with the code book IS 800-2007. So, it taken both strength and serviceability into account. So, limit state method addressed both the factors, that is strength, limit state of strength and limit state of serviceability. So, limit state of serviceability is minimum deformation, deflection, crack, vibration, corrosion, and to aesthetic view, functionality and safety of the structure were taken into consideration. So, hence limit state of serviceability was accepted. Next, limit state of strength. Structure should be stable and not collapse under any load. So, these two were considered in the limit state of method. So, limit state of strength and limit state of serviceability played a crucial role in this design. So, gamma F and gamma M. So, where gamma F is a partial factor of safety and gamma M is a partial factor of safety for the material. So, based upon these two, we are going to design the limit state method of design. So, this is about the introduction for the design strength, design of steel structures.